And then if the other one is acidosis, then you write compensating. Right? Did that make sense?
Yeah.
Okay. But if the other one is still normal, then you say uncompensated. Or if both of them are in the direction of alkalosis, then you say combined respiratory metabolic alkalosis. And you do the same with acidosis. Okay? And then, Jade, I'm going to answer your question downstairs. Okay, so now we're in the last, and any more questions before we talk about this one? Any more questions? We have another worksheet downstairs for the renal system. People are going somewhere, scheduling vacation, missing precious time period, which is so important. Okay, so the reproductive system is always the last body system. Any A&P book will always have this in the last because they say that the first 10 body systems were really for maintaining your day-to-day activity. And in this one, they say it's important for maintaining the human race. That's why they put it all the way in the end. But it's still important. Okay, so we're going to talk about here the anatomy of the male and female reproductive system, and then the physiology of the different that body system. Okay, we're going to talk about the bojangles. I call it the bojangles. Okay, so a few terms that we must know. We must know gametes, which are the eggs, the eggs and the sperm. They're called gametes, or the sex cells. They are gametes. And they're produced, I'm sure you know, how do you form the sex cells? What type of cell division? Meiosis, right? To produce. So this one, they're haploid. Do you remember from biological one? Diploid, haploid. And then when we, during the sexual intercourse, when one gamete meets with an egg, when a sperm meets with the egg, that's called fertilization. The match that one. They meet together, fertilization. And then the sex organs are also called gonads or vagina. So like in the two sex organs, in the male, it is the testes. Not the penis, but the testes. In females, it's the ovaries. Those are the two gonads, not the cells. Then the others are called accessory glands or organs, accessory organs. But the two main gonads are the testes and the ovaries. So it says here, that's where the gametes are produced. So we will call gonads the organs that contain the gametes. You're familiar with gynecology, you're familiar with urology. So we always start with the male reproductive system because it's the easiest. The gonads here are the testes, and there it is. That's where the precious jewels are formed, right? That's where it's produced. And then, of course, it has to be released out. So all of these structures are called ducts. So they're called ducts, and we're going to name them until they're released, and hopefully they land in the vaginal area and they meet up with the egg somewhere up. Okay? So we're going to talk, first, we're going to talk about this part, the testes, and then we're going to talk about the other accessory organs. Okay? When it comes, the sperm is formed here, it's produced there, and as it passes out, it gets secretions from three important organs, which we're going to talk about: the prostate gland, the seminal vesicles, and the bulbourethral gland. We're going to talk about that. But all of that, the sperm plus the secretion from those three glands, is what you call semen. So semen is sperm plus the secretion from the three glands. There's never urine in semen. Even though this is the passage for urine also, semen should never contain urine. If it had urine, then the sperm will die. And that's the purpose of the secretion from the other glands. This slide shows us the importance. Why do you think first? Why is the testes, this is the testes or called testicles, why are they outside of the body cavity?
To regulate their temperature.
The temperature, that's right. So the testes has to be 1 degree cooler than body temperature. So that's why they're outside. If they remained inside, the sperm will die. They have to be 1 degree cooler. So they're outside. Are they in the pelvic cavity? No, they are outside. They're not in any body cavity. And there's two. So your testes can be exposed in cold conditions or warm conditions, right? So here on the right here, the blood vessels, this one is what helps the testis or the sperm when it's warm. If you look at this picture right here, you see the testicular artery. I only see 1, 2. But then look at the veins. It says plexus of veins. You see the pampiniform plexus of veins? What do veins do? They carry blood what? Back to the heart, right? So away from the organ, back to the heart. So if it's hot, this artery is carrying or delivering warm blood. Remember, the blood is the one that delivers the temperature, the hotness. So this is carrying hot blood that supposed to go here. But what these plexus of veins do is they pick up the heat that's being evaporated or radiated from this, so that they take away the heat and only the blood goes here. So the plexus of veins, the pampiniform plexus, is very important when it's hot or when there's increased temperature. When the temperature is down, when it's cold, this is the one, the muscles. The two muscles are the one that help. The dartos, which is smooth muscle, and the cremaster muscle, which is skeletal muscle. This is an extension of your obliques. See, the external oblique, which is skeletal muscle. The two muscles, what do? They will contract, right? That's what muscles do, they contract. So when it's cold, they contract to bring the testes closer to the body of the male, so that the temperature will be a little bit higher to warm the testes. The point is they have to always be in at least 1 degree cooler. Okay? So now you know the two ways that the testes are able to thermoregulate. This is why they say do you remember the laptop when it first started coming up? People put it in their laps, the guys, and they develop all kinds of, is it infertility? I always mix it up. Problems in their, their thing. When they do the heat, right? And even the cell phone, all that stuff, that's why they put it in their butt now. But right here, they put it right there now, or in their pockets right here, because of thermoregulation. Okay? Okay, so that's the purpose of this picture. Don't forget, on the right, for thermoregulating when it's hot, on the left, when it's cold. So the two muscles. Okay? Okay. Okay, so now, what they did is they cut the testes, which I want you to look for in your cat. That will be our next activity on Wednesday. Today we're doing all now. So once you look for the testes in the cat, you're gonna cut it like this. Do a sagittal cut. And you're gonna see that the cat is made up of nothing but tubules. Like the pipes that you, or tubules. Renal system, remember? Lots of tubules in the renal system. This is the same thing. This is nothing but tubes or pipes. Okay? And you're going to see that it's very granular downstairs. When you cut it, it's very small, but you try to, when you open it, try to maybe stretch it a little bit. You'll see all of the tiny little tubes, like worms, but there. So the testes is made up of nothing but what you call seminiferous tubules. And the seminiferous tubules is actually where the sperm is formed, and then it will, they finally, look at all the seminiferous tubules. They collect into these ready testes. Do not worry about too many terms. I'm going to tell you what I want you to remember, okay? So the seminiferous tubules will empty the sperm here to the ready testes, and then finally, look, empty to the epididymis, which you must know. Seminiferous tubule, epididymis, and look at the epididymis becomes the vas deferens. And I'm gonna have a picture over here, right here, right? So that's where the seminiferous tubules are in here, in the testes. And what we see here, this one is the epididymis. They collect in the epididymis, and look at, it's gonna have, you have to empty the sperm out of the testes. They're gonna pass through the vas deferens right here. See, passing through this inguinal canal in males, okay? They have to enter the pelvic cavity and exit through the urethra out, okay? So if I look at this picture, the opening, the urethral opening is, or the testes are pretty safe from any germs here because the urine is always acidic, and they're protected basically. But one thing you must know about males, which we're gonna see the difference between male and female. This is the inguinal canal, right? So you know that the testes, the vas deferens, see, it pierces the inguinal canal so that it can enter the pelvic cavity, go over the bladder, come out to the urethra, and there. So in other words, in males, the inguinal canal is actually pierced. There's something that occupies the inguinal canal. It's the vas deferens. So that's why inguinal hernia is very, very common in males. Females also have inguinal canal, but we have a covering. There's nothing. We have no vas deferens, so it's not pierced. But with males, it's pierced because the vas deferens has to come. See, it has to pierce that to be able to enter the body cavity, which is not the case with females. So if I ask you what's inguinal hernia is more predominant in what population? Males only. Because of the actual opening of the inguinal canal. In females, we don't have that. And I'm going to show you what females are more prone to, which is more dangerous. Okay? Okay. So you got that question on inguinal hernia? Okay, so you must know seminiferous tubules, you must know epididymis, and then the vas deferens. So if you do vasectomy, you now know where they do that cut. So they cut the vas deferens right there, somewhere there, and then they just tie a knot. They can reconnect. So that means if you have someone who has had a vasectomy, it doesn't mean that they don't have any more precious jewels, because this is still doing it, right? It's just the exit is being blocked. So what happens to the sperm that they produce if you had a vasectomy? They just undergo normal death. They have an expiration date. What's the normal cell death? It's called apoptosis. But the cell death of sex cells is called atresia. So sometimes maybe you'll see some pathology report. I see some atretic follicles in the ovary, so you know what atretic means. It's dead. Okay? Just normal cell death. So they just stay there. And then they just get broken down to organic and inorganic compounds. So in utero, this is how all of us whether you're male or female, sorry. Whether you're male or female, the gonads are located inside the abdominopelvic cavity for both male and female. So we were embryos in our mother's uterus. Both, we all have a primitive gonad and it's inside, all of us. If you have the Y chromosome, then you're going to be a boy. You don't have the Y chromosome, you're going to be a girl, right? And the presence of the Y chromosome plus the testosterone makes this a testis. Okay? And what happens is there will be a gubernaculum testis, which is, who has ever gone inner tubing? Sorry, what do you call that? Zip line, zip line. Have you done the zip line? If you go to, what's that? Great Wolf Lodge, they have zip lining, right? So you zip line. So just imagine there's a connective tissue here called the I don't ask you this one, okay? The point is the testis usually descends. Before the baby is even born, the testis descends. And you're wondering, how does it descend? Because you look at the cat, the testis is already down here. It started up there. So imagine if you have female cats, right? Some of you have female cats, you see where the ovary is. Imagine that to be the testis. And you see that there's a fallopian tube, the ovary, right? So imagine the fallopian tube to be the gubernaculum testis, which is nothing but connective tissue to zip line. Don't ask me how. God designed us. But that's what happens. They use the zip line, the gubernaculum testis, which is a connective tissue. They use that as their guide. So they go zip line, and then they land here. So when they're born, they should have the testis down here, right? Some babies are born with undescended testes or cryptorchidism. Where is that? Cryptorchidism means undescended testes. And you know the danger of having an undescended testis. What's the danger? Yeah, the progenitor, the sperm will die, right? Because it's going to be cooked in there. So they have to descend. They say, nothing to worry about because by usually the first half of the year of the baby, it usually descends on its own. Sometimes 6 months it's still up there. All they need to do is just go pull it out. Just dive it down. Yeah, it's not a very difficult procedure. They just pull it out. Okay? But you have to bring it down. Okay? Okay. So that's, and when you pull it down, it passes through the inguinal canal. That's the only way it will pass down. From inside the body cavity, pass through the inguinal canal. And so now there's an opening, which is what the vas deferens takes advantage of. So it can come out through the urethra to deposit the sperm to the vaginal area. So there are 3 important cells that you find in the tissue. I'm going to go to the next slide. Okay? Right here. What they did in this slide is they cut this one. So imagine you cut this like this. So you cut and then you're looking at the circle. Like I cut this and now I'm looking at it that way. So now I'm looking at the inside, right here, okay? So this is one tubule, there's another tubule, there's another tubule. I see 3 seminiferous tubules in this picture. You have any question on the way it's cut? And you see cells inside the tubule and outside the tubule, okay? Do you see the cell with the tail? That's the sperm, isn't it? Okay, see the tail? That's the sperm. So inside the tubules is where you find the sperm. There are actually 2 types of cells inside the tubules. Of course, you know one of them is the sperm, the one with the tiny little tail. They're just waiting to go inner tubing, go swimming. Okay? You ever You ever go swimming and your legs are dangling at the edge of the pool? That's what they're doing. See, their legs are dangling. They're just waiting to go swimming. Okay? So most of the cells here are the sperm cells, and the primitive sperm cells are called spermatogonia. Spermatogonia, meaning that's the primitive sperm cell, or like the stem cells that we were, remember the osteoprogenitor cells becomes osteoblast, becomes osteocyte. You remember that in chapter 6? So this, the spermatogonia becomes the sperm cell. That's your primitive. And so which one is the mature sperm cell? I assume it's the one with the tail. So I think there's the sperm cell, and I think that the spermatogonia are right here close to the wall. Okay? There's another, see, it says spermatogonia right here. Okay? And if you, this is very nice to look at downstairs. If you have time, you look at them. That's where you're going to see lots of cell division. Like the onion root tip, right? You see cell division. You're going to see cell division there, if you have time. Okay? Okay. Another, see, there's a cell division. There's lots of cell division. There's prophase, lots of prophase, I see, right? Okay. Then another cell that you see inside the tubule is called the sustentacular cell, right here, or the Sertoli cells or nurse cells. That's their name. They have 3 names, right? You can call it sustentacular or Sertoli or nurse cells. That's their name. So we talked about the sperm cell, and then there's another cell inside the tubule. What do? They nurse. Nurse Jackie. You ever watch them? They nurse the sperm cells. They support. You must highlight the word blood-testis barrier. So, you look at this picture right here. The sperm is up here. What is the chromosome count of a sperm cell? What's the chromosome count? If they are haploid, they must have 23. Is 23 human or not? A human cell should have how many chromosomes? 46. So they are not human cells. That means your own immune system can attack them because they're non-human. And that's why you need your sustentacular cells there. They form a blood-testis barrier. You know that your white blood cells are in your blood, right? So if the white blood cells see these non-humans, I watched too much of that Shield, Age of Shield. If you see these non-human haploid cells, if the white blood cells see that, they're in trouble. They can attack them. So the job of the sustentacular cells is to form that blood-testis barrier. Somewhere here there should be a blood vessel, but I don't see it in this slide. So it's very hard to figure out which one is a sustentacular cell and which one is a, the sperm cell is very easy, but the sustentacular cell is very hard to figure out which one is which. I just usually ask what cells do you find. But if I point to the cell with the tail, it's obvious. That's the sperm cell. Okay? Okay. So those are the 2 cells that you find in the tubule. Now we're going to look at the cells right here. You see that they're between the tubules. They are in the tissue spaces in between the tubules. The name of the cell there is called interstitial. In between the interstitial cell of Leydig, or the Leydig cell. And they have a function. You see what they do? They make testosterone. So this cells, the sperm cells, we know that they have to undergo meiosis, right? And that process of meiosis needs a level of testosterone all the time. That means they have to be exposed to testosterone for meiosis to be successful in the sperm cells over here. And that's the job of the the Leydig cells. They make testosterone. Look at this. As another function, by the way, of the Sertoli cells is they have the androgen binding protein. I forgot. So the Sertoli cells make the blood-testis barrier, and they also have androgen binding protein. I have a guess that this is a Sertoli cell and that this is another Sertoli cell. That's just my guess. If it was stained, then I can be correct, but I'm not sure. Anyway, so these cells, they have androgen binding protein. Just by the name itself, what do you think it does? What will that protein do? It will bind, correct, bind the testosterone, right? So the Leydig cells make testosterone, they diffuse inside, and they accumulate, or they're stored, they bind to the androgen binding protein of the Sertoli cells, so that the sperm cells here are always exposed to testosterone. So they will have no problem with the meiosis. All three cells have their own role. Look at your notes. Let me know if you have any questions.
Here's the last part, about the ABP.
So the Sertoli cells have the ABP, right? So this one is the one that makes testosterone, the Leydig cells.
Okay.
So they release the testosterone. Now the testosterone will enter here, and they will be stored by the Sertoli cells. It's bound to their androgen binding protein.
Okay.
So that the sperm cells are always exposed to testosterone, which is needed. Testosterone is needed for this to happen. Yeah.
Is sustentacular underneath this Sertoli?
Yeah, Sertoli, yeah.
I just wanted-
Yeah, the three of them. See, they're all the same name. It says or, Sertoli cells, or sustentacular, or nerve cells. Okay? Are we good? So how do we form our sex cells? Meiosis. So we have to review meiosis very quickly. You remember this one? We start with, so the spermatogonia and the oogonia, those are the parent sex cells. They contain 46 chromosomes, right? So we're talking about spermatogenesis first. So we have 46 chromosomes, but actually you have 44 autosomes and then the X and the Y, right? You're a male. And then in preparation for cell division, you have to double up. Remember? We double up. So we double up with the X and the Y, remember? And we go through meiosis 1. So what is this one? The parent spermatogonium? Is it diploid or haploid? Diploid, right? Diploid is any cell that contains both sets of chromosomes. I had 20, so we're gonna say here. 23 came from your mom, right? And 23 came from your dad. I have a guess, I think I'm correct. My guess is the X came from the mom. Is that your guess too? Okay, and my guess is the Y came from the dad, right? Okay, so in preparation for cell division, you have to double up first. So which means we'll make a copy, right? Double that one. Remember from by 241, we're not going to go into detail for this one. And then meiosis is cell division. So what are the steps in cell division? It is still yeah, right? So it's the same term. When they divide, whether it's mitosis or meiosis, it's the same term. They will look the same under the microscope. The only way you can say this is meiosis is if I told you this is a slide of an egg cell, because they look the same. If they don't look the same, you give them different terms. But it's called prophase, metaphase, anaphase, telophase, because they all look the same. Okay? So there's two cell divisions in meiosis. So we call it meiosis 1, which is prophase, metaphase, anaphase, telophase 1, right? And then we produce two cells, right? After meiosis 1, where one set plus the copy of that one set goes to 1, right? And the other set plus the copy of that other set goes to the other one. What's the chromosome count here? Oh, not 23. Why did I write? You guys, you didn't correct. It should be 22, right? So 44, 45, 46. What's the chromosome count of each of these cells is 46, right? But it is diploid or haploid? It's haploid. It is 46. So this is diploid or 2N. This is haploid now, or N, because it only contains half the set of chromosomes. Meiosis is a two-step cell division. So you go to the second meiosis 2, another prophase, metaphase, anaphase, telophase. You know how they look like under the microscope, right? And now you form your 4 cells with just the 23 chromosomes. It's haploid all the way. Okay? So you review haploid, you review meiosis 1, meiosis 2. Meiosis 1 is referred to as the reduction division, and that's referred to as the equation. Don't worry about those terms. It just means you're reducing it from diploid to haploid, and now you're dividing it into 4. Meiosis 1 is a very important process because of this one. During prophase 1 means it's in meiosis 1. Prophase 2 means we're talking about meiosis 2, okay? So prophase 1, meiosis, metaphase 1, anaphase 1, etc. So during prophase 1, and only during prophase 1, there is tremendous exchange of information between the homologous chromosomes, the like chromosomes between the mom and the dad. So that's where first the like chromosomes, they fuse together, and there's what you call the crossing over. And so if you look at this, the result over here, you see this one where they cross over. Look at this slide. I like this picture. You see, first this was all yellow and red. And now you look at what happens after crossing over. There'll be the yellow, there's some red here. And this explains why we don't look exactly like each other. Sometimes you get these that, oh, maybe you're the daughter of a postman, or whatever, that is some rude comments because you look so different. That's because of that tremendous exchange of these alleles between each chromosome. Okay? And that's what you call crossing over. Where does it happen? During prophase 1 of meiosis 1. And then look at it, looks the same, right? Metaphase, anaphase, telophase, looks the same. You can tell under the microscope. Okay? You already know what happens, except that, look at this one. You see what's happening? You're separating your chromosomes, but there's a variation now. And that's how we all look so different. Because we have the same mom, there will be some difference between each other. Okay? Question? 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 So the cells that we're talking about, the sperm cells, they look like this in the beginning. Like the cell that we studied in chapter 3, remember? The nucleus, the cell membrane, all the organelles. That's how it looked like in the beginning. But you see, so the formation of the sperm cell by cell division, by meiosis, this is called spermatogenesis. When they mature and assume their shape like this is called spermiogenesis. So spermatogenesis and spermiogenesis are two different terms. Spermatogenesis, in other words, is meiosis, right? Spermiogenesis is just changing or maturing of the sperm cell that was produced by your spermatogenesis. You got that? Okay? Okay. So look at this one. What happens is they have between the sperm and the egg. Who has a hard life? What is it? In the beginning, it's the sperm, right? In the beginning only. Because they have to swim. So they have to travel light. Okay? And that's why you see what happens. That's too much, that's too heavy for them. If they had a big head, it's going to be difficult for them to carry that head. So look at what happens. They shed off most of their contents. Look. And they develop this flagella. So what they finally look like when they are fully mature is this one. They contain a head which contains the 23 chromosomes, either 22X or 22Y, right? Plus an acrosome right there. That acrosome is very important. It has a helmet. That helmet, the acrosome, contains a lot of hydrolytic enzymes, actually. They need that. They have to. Do you buy eggs?
Yeah.
You know how eggs. You have to crack the egg, right? To cook, to eat, whatever. So that's the same with our eggs. When we ovulate, our eggs have an egg shell. So that shell has to be cracked. Those enzymes in the helmet is very important to crack the egg. Okay? That's why they have that. Think the football players, whatever. They are the only ones with the helmet. I think so. They need that. So no acrosome, you know what it contains: enzymes, hydrolytic enzymes to just break through or to crack the egg. And then they have, and plus here, that's the nucleus that contains the 23 chromosomes, either 22X or 22Y. Okay? And then it has this neck, which is nothing but mitochondria. What's the function of mitochondria? The powerhouse, very good, for ATP. And then flagella, which is for swimming, right? That's all. That's all it contains, guys. Just the nucleus with the 23 chromosomes, the acrosome, the mitochondria, and then the flagella. It has nothing else. That's why it has to rely on the accessory organs to provide a care package that they will need on their hiking trip. Okay? So those are the components of a typical sperm cell. A sperm cell, by the way, there's normal and abnormal, right? The normal, do you know the normal volume of semen? It's about 3 to 5 mils, right? Per release is 3 to 5 mils. Do you know the normal sperm count? What's the normal sperm count? What's your guess? 50 to 150 million per 1 mil. Actually, if the sperm count is 20 million per 1 mil, you are sterile. That just gives you an idea of how important most of them will die. They're being deployed in enemy territory. Hello. That's when we need all of those. And not only that, look at this one. You know, to be not branded, to get the diagnosis of sterility, that's just a big deal, right? So they take the time, they look at every single cell that you have. It should look like this. Look at this. Sometimes this is what you release. That's not going to work, right? Or the tail is bent. Nope, not going to work. Sometimes may have 2 heads. Not going to work. It has to be like this. Now, before we, where is that sun? There's something very important that you must know over here. Oh, there's the cell division right here, which I skipped right here. This, now we looked at, earlier we looked at the picture of the tubule, we saw the cell inner tubing. This, and we just finished meiosis. This one is a slide with that one using the different sperm cells. Right? We started with the spermatogonium. Look at this slide, guys. This explains why guys can be Mac Daddies forever. You heard of some people 80 years old, 90 years old, they become daddies. Never ending. Look at this. The answer is the word mitosis. Do you see the word mitosis there? Which you will not see in females. So there's the spermatogonium for the male. Look. Before it divides, it undergoes meiosis. What's the first thing that it does? Mitosis. To produce 2 cells. One is in the reserve. One is devoted to divide by meiosis. So they have never-ending Mac Daddy. Right? Never-ending. They have never-ending reserve. And the one that is devoted for meiosis will be called primary spermatocyte. And then it will divide after undergoing second meiosis 1. You produce 2 haploid. It's called secondary spermatocyte. And then meiosis 2 will produce the 4 sperm cells. Look at this picture right here. This is a big deal. Okay? There's 2 big deals here. In males, the mitosis, that's your, like I told you. And then there's another big deal here, which you don't see in females. It's the fact that all 4 of them, there's equal sharing of wealth. They all have the same size, same everything, which is so different in females. So I want you not to forget those 2 big deals. The mitosis up there, and then these 4 equal size sperm cells. All of them are alive. The guys need all the soldiers that they can produce. So only one will be enough. Okay? Question on this one? On that's the term primary. Primary just means you're primarily going to undergo meiosis, right? And then after meiosis 1, you're now called secondary. And then after meiosis 2, you're now called the sperm cell that we are familiar with. Okay? So the entire process of sperm maturation and development needs testosterone. And here is where we need the endocrine system. Okay? So this slide is showing you remember the hypothalamus that releases the gonadotropin releasing hormone. It goes to the anterior pituitary, and the anterior this is, by the way, the same hormones that you're going to see for the female also. The anterior pituitary releases FSH and LH. Those are the two hormones that target the reproductive system. And for males, there's only one target organ, the testes. There's nothing else. So these two hormones go to the testes. And look at the target organ of the FSH. FSH means follicle stimulating hormone. The FSH targets the cells inside the tubule, which is my sperm cell and my Sertoli cell. The LH, L for Leydig, they target the Leydig cells outside the interstitial cells there. That's what they target. So what do they tell the Leydig cells? They tell them to make testosterone, which is needed for this spermatogenesis to happen. What is FSH telling? It's telling the sperm cells you can proceed if there's normal levels of testosterone. It's also telling the nurse cells to make this androgen binding protein right here so that they can store the testosterone. I want you to look at this. It's very important. This happens, by the way, at puberty. When we hit puberty, this starts happening. So this is the story of the male, right? In utero, you have high testosterone, so you can form your testes and it can descend. When you're born, at birth, the testosterone levels goes down. Don't ask me why. Maybe that's God's way of protecting the babies from becoming bad. Yeah. And then don't ask me why when we hit puberty, all of a sudden, this starts happening. Negative feedback. So it's different for each and every one of us. Puberty anywhere from what? 12, 13, whatever. 25. Hit puberty. Okay, so look at this one. I want you to look at this testosterone. So in addition to promoting this spermatogenesis, there is this form of testosterone which came from that, guys, that's two different things. That came from this one is called DHT, dihydrotestosterone, which is the one that's responsible for doing all these, right? The secondary sex characteristics. They bulk up. What do you think happens? One of the things that this one does is it increases RBC production also. But just look at this, okay? This one has nothing to do with this. So guys, this is what's sold in the store. So people buy it and they look sexy, right? You want to date them. You want to marry them. Then you get married, you can't have kids because this is different. And what are you telling your brain? Negative feedback. You ingest that, you're telling your brain you have enough. So the brain is not releasing that. This is no longer making anything. These are two different things. You see, testosterone is different from that. So they have what you call sweet peas. The testes shrink when you take when you ingest the steroids. Because you're telling your brain you have enough. What will the test do? It will just shrink. It's not being used. You lose it. Okay? And they are prone to developing stroke because the hematocrit goes up. We pick up from here. Bye-bye.